Alright, welcome to a video on looking at circles and arcs. So to begin with, let's define what an arc is. Well, hopefully we know what a circle is, right? You've got a center of the circle and everything is the same distance apart, which is the radius. Okay, so getting that out of the way, let's talk about an arc. So an arc is a part of the circle, so like from here to here. Okay, it can be measured in degrees. Or it could be measured in linear units such as length, like feet, inches, miles, yards, those types of things. Okay. When we measure it in degrees, we call it the measure of an arc. And it's going to be equal to the measure of the central angle that corresponds to it. So this arc DE would be the same measurement as this angle right here, angle DCE. So a central angle is defined as an angle with a vertex at the center, and the sides are two radius, or radii is the plural of radius, that meet the end points of the arc. So you can see I drew a radius from C to D, which is one end point of this yellow arc right here, and from C to E. So there are three different kinds of arcs that we're going to talk about. The first one is called a minor arc. A minor arc is, I want you to think of it as less than half of the circle. So half of a circle would be 180 degrees. So if it's x degrees, remember the arc and the angle are the same. If it's x degrees, then it's going to be between 0 and 180. Okay, and how we name them is with the two end points. There's only two letters for a minor arc. Okay, so this one I have here is the example DE, from D to E. That's less than half a circle. EB, AD, AF, FB. Now if you're thinking, what, FB? Yes, FB is less than half a circle. So one common issue that people have is thinking of acute and obtuse angles. No. Acute and obtuse would both fit under minor because they're both less than 180. Let's do, how about F to D? We do not want to put the letter A in it. Okay, we're just, because it's a minor arc, we're going to go from F to D. There's a lot more on here. This is just a couple of examples. Let's clear this all out a little bit. Okay, let's talk about a major arc. So with a major arc, we are going to be more than half of the circle. So we're going to go from 180 degrees, but still less than a full circle of 360 degrees. So to name them this time, we're going to use three letters. You basically go end point, and then another point that's just in between, and then to the end point. Okay, so for example, I could go F all the way to B, but I need to use one of these 3 points in between that I passed. So I could use any of them, but only one of them. So like FDB would be this arc, or FEB or FAB. Or you can go the other direction. You can start with B and end in F. You can do BEF, BDF, BD, or BAF. There's so many ways you can name the same arc. But if you just used two letters to describe this, if you just used FB, you would be describing the minor arc going the other way in the circle. That's why we have to use two letters for minor and three letters for major to differentiate. Okay, let's find some more major arcs. We could do A through F. So we can call that AEF. We could do D to F, DBF, etc. Okay, a semicircle is half of a circle, so it's exactly half. So it's exactly 180 degrees. And we're gonna need three letters in the same manner. So the same as a major arc is how we're gonna name it, because even though it doesn't matter which half you use, it's gonna give you the same measurement either way. We do want to have a way of describing which half. So if I'm gonna do this half, so what I'm looking for is a diameter. You should see a diameter to get a semicircle because that's gonna cut the circle in half. So if I'm talking about that one, I could call it FBE. If I'm talking about the other way, I can call it F, and then I need either A or D. I'll just use A, E. Okay, so there's two semicircles. You could use this diameter right here, get a couple more semicircles that way. So AEB and maybe AFB. Okay. All right, one more thing that we're going to talk about before we talk about circumference or arc length is the arc addition postulate. So just like we had a segment addition postulate and an angle addition postulate, we have this thing called the arc addition postulate. Basically what we have here is, let's say we have an arc AB, and to name to the measurement of the arc, just like with angles, we put an M in front of it. So the measure of arc AB, and we put this little arc over it, in case you didn't catch that when we were talking about the name of it, you put a little curvy arc over it. If I take that arc and I add it to the one right next to it, BC, so the measure of BC, that would equal the measure of the overall arc from A to C. Which there's no diameters here, but if this is the center, this might be just barely, this is a little over 180 degrees, so I'm going to call that a major arc. So I'm going to use three letters, so ABC. Okay, let's switch to the examples temporarily, and then we'll talk about circumference and arc length. Okay, so here we have a circle. One other thing I want to point out is how to name a circle. We name it by its center, which is M, and we use a little circle with a dot in front of it, or inside of it. We don't put just a O because it would look like the letter O or the number 0. So this is circle M. Okay, anything that you see that looks like it's going straight through the center as a diameter, you can assume it's a diameter. Okay, so the first one we need to find is ET, arc ET. By the way, my notation here looks like it's a little bit more like this instead of like this. That's because sometimes this curvy symbol is a little difficult to find. This is the closest I could find. Alright, so arc ET goes from E to T. It's a minor arc. Alright, there's nothing here, but can you see that this angle right here is vertical to this 55 degrees? So we can use vertical angles to say that that central angle is 55 degrees, so the arc is 55 degrees. They're just equal. Okay. TFE is next. So from T through F all the way through E. So it's got 3 letters. It's a major arc. So in this case, I can see that it's the rest of the circle from that 55 degrees. So I'm going to do 360 degrees, which is the full circle, minus the 55 degrees, which gives me 305 degrees. All right, so that's the yellow one. Let's do ES. Where is ES? So from E to S. Now, if you're worried about like which way do I go, it's only got 2 letters, which tells you we're going this way, not the other way. Okay? If it was 3 letters, we would go the larger way. All right, so from E to S, I could see that I can add, use the arc addition postulate to add 55 plus 90. Which is 145 degrees. Alternately, you could subtract, you could take the full circle, subtract 360 from, well, this is 180. And, well, this you'd have to find. So maybe that's not the easier way. There are multiple ways to do these. There's multiple strategies. All right, our last arc here is EUS. So that's 3 letters, which is telling me to go from E to U to S. Okay, well, I know that this pink arc is 145 degrees. So one way I could do this is take 360 and subtract, oops, not 2, 145 degrees, which I believe gives you 215 degrees. Alternately, you could add. Like I said, you could figure out what this is. This is, well, this is a diameter, so that's a semicircle. That's 180. This turns out to be 35 degrees. To get the 35 degrees, you could take 90 and 55 and subtract it from 180, because this is a semicircle. So that's another way. So then I can add 180 plus 35 to get 215 that way as well. All right, now let's talk about circumference and arc length. The circumference of a circle is basically going to need a number 9 called pi. But let's just describe what it is. Circumference is the distance around the circle. It's the length. Not 300, not in degrees. It's not 360 degrees. It's if you were to measure this in inches or centimeters or feet or whatever. If you were to wrap a string around the whole circle and then measure out the length of the string. Okay, and so we use this number pi. The number pi is a ratio. It's the ratio of the circumference to the diameter of the circle. Okay, and we know it's about 3.14. That's an approximation. You should be able to find a button on your calculator that says pi, and it'll give you the longer one. But where most of the time you're not going to need to use the pi, you're just going to leave it in terms of pi, which means don't multiply by the pi. Just leave the pi there, because it's a more exact answer. Okay, so using this definition that pi is the ratio of the circumference to the diameter means that pi will be the whatever the circumference is to the diameter. The diameter is the whole length, which is, and the diameter is half of the radius, or twice the radius, sorry. So the radius is half of the diameter. So if you multiply this equation by the diameter, you get one of our formulas. The circumference is the pi number times the diameter. Or if you use radius, it's 2 times the pi times the radius. The 2 and the r are the d, the diameter. So that shouldn't be too new to you. You should probably seen that before. So now we're going to talk about arc length, which is a little bit more newer. So here what we're doing is we're measuring the arc in not in degrees, but in length units like feet, meters, inches. So arc length, unlike the measure of an arc, which is measured in, oops, let's not use a highlighter to write here. So arc length is measured in linear units, like I said. So think inches, feet, yards, etc., instead of just degrees. Think of it as how long would a piece of string be on part of a circle. Okay? So the way that we were going to think about it is it's a ratio. It's a fraction of. When you're finding the length of an arc, you're finding a ratio of the circumference. The ratio we're going to use is dependent on how big the arc is. If you have a small arc or a big arc. So you want to know how many degrees this is, which is the same as the degrees of the arc. So we're going to use the degrees to give us an idea. Since a full circle is 360, we're going to take that degrees and we're going to divide it by 360. That's the ratio we want. So if it's like 180, 180 over 360 would be half of the circle. And then we're going to multiply it times the circumference formula, 2 pi r, and that gives you the arc length. So there's two things you got to do. You got to find the radius, which is this distance, and you need to find the degrees, which is either here or here. Okay, let's give it a try. So we've got two more questions here. First one says a car has a circular radius of, or circular turning radius of 16.1 feet. The distance between the two tires is 4.7 feet, so that's the distance between your circles. How much further does a tire on the outside have to turn than a tire on the inside? So we have an outside circle, which is larger, and an inside circle. And so they have two radii. So the outside circle has a radius of 16.1. The inside circle is from here to here, and so we're going to subtract 16.1 minus that 4.7 to get 11.4. Okay, so we're just going to find the circumference of each circle and then subtract them. So let's do the circumference of the outside would be 2 times pi times 16.1, which is about 101.16 feet. And the circumference of the inside is 2 times pi times 11.4, which is about 71.63 feet. And then we just subtract them. So the outside tire travels, we do a little subtraction, 29.53 feet farther than the inside tire. All right. Find the length of the bold arc, which is this one right here. Okay, so we're doing arc length. It also tells us to leave our answer in terms of pi. So we need the degrees. How many degrees is this? And we need the radius. If you see a diagram like this and you have a number kind of in the middle, that's the length of the diameter. If they're going to make it the radius, they'll make it obvious. So this is the diameter is 18, which tells us the radius is 9. And since this is a diameter also, that's a semicircle right there. From here to here is 180 degrees. So this 30 degrees that we have right here, we can subtract from 180 to get that this is 150 degrees. Okay, we have everything that we need. Remember, you take the degrees over 360 and multiply it by the circumference. Okay, so we're going to do 150 over 360 times 2 times pi times 9. By the way, the circumference, you could replace this with pi times d, and that's fine also. Okay, so when they say leave it in terms of pi, I want you to think of like cross-canceling and reducing a fraction. So like these zeros will cancel. 2 and 9 is 18. 18 goes into 36 twice. So I have a 15, I have a pi, and in the denominator I have a 2. And that's all you want to do. We can call that feet, but that's what they mean in terms of leave it in terms of pi. All right. Thank you for watching.